dear students. So for today we are going to take a look into a few more multiple choice questions. You can expect such kind of questions in your JEE mains and NEET examination. So let's start with the first question. What it says, a 3D electron having S is equal to plus half can have a magnetic number as. Now, we are speaking over here with respect to the 3D electron, right? So, they are asking how many of them or how many electrons can have the value of S is equal to plus half in the particular magnetic quantum number. Okay, so let's observe. So, when we are speaking about 3D electrons, so 3D orbitals. First, when we take a look into the 3D orbitals, we need to understand what are the magnetic quantum numbers for this. So, the magnetic quantum number which are available for the 3D type of orbitals are, if you remember, it is -2, -1, 0, +1, +2. These are the values for M, right? So therefore, when we take a look into the orbitals of d subshell, 1, 2, 3, 1, 2, 3, 4, and 5, right? So now 1, 2, 3, 4, 5. 5 values, it is something like this: -2, -1, 0, +1, +2. Okay, now they are asking a 3D electron having plus half. Remember this, plus half, that means it is of only one particular spin like this, right? An unpaired electron is going to be of plus half. Okay, of course, if we are having like this, then it is going to be a minus half for a downward arrow. And of course, if it is in a condition like this, we call it as a paired electron. So these are our paired electrons. So when we are filling this particular thing, so what we are going to have is 1 plus half plus 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 plus. Okay, so can I say this is plus half plus half plus half plus half and plus half over here? But as it starts pairing, okay, the spin cancels, spin cancels, spin cancels, spin cancels. So I can have only one electron with plus half in +2 orbital of 3D subshell. So the answer here is the +2. Okay, so quite one particular answer over here, and that is for the +2. Let's take a look into the question number 2. What it says. The correct set of 4 quantum number for the unpaired electron of chlorine atom is. Alright. When we take a look into the chlorine atom. Now, chlorine. Okay. So, how to understand such kind of problem? First thing is that we need to understand the atomic number. Once you have the atomic number, you can go for the electronic configuration. Once you have the electronic configuration, entire answer lies over that. Okay, let's not take a look into the options there. So first one, what we have is the atomic number. Atomic number of chlorine becomes as 17, right? So atomic number 17. So electronic configuration as what we fill this one: 1s2, 2s2, 2p6, 3s2, 3p5. Let's count. 10, 11, 12, 12 plus 5, 17, right? So now, observe this for the answer. Okay, let's observe the last one. So, in the last case, what we have? We have as 3p5, right? So, what is going to happen? N is equal to 3. Okay, the value of L for P. Remember the value of L, azimuthal quantum number for the P subshells are going to be equal to 1. Okay, now we need to understand as how we are going to fill this 5 electrons in the p orbital. So, the p orbital, as what we know, is going to have as px, py, pz. I can also call it as -1, 0, +1 with respect to magnetic quantum number, that is M. Okay, so now when we observe it here, we have 5 electrons to fill this up. So according to the Hund's rule, when we fill it up, what we are going to have? 1, 2, 3. Right? Similarly, first we need to occupy all the orbitals. Okay, how many we have? 5. Out of 5 we have filled 1, 2, 3, 4 and 5. Right? So what we have here is the answer over here for M is +1. Okay, so total answer I should find it out something like 3. Okay, next one should be 1. Next one should be 1. Okay, so the particular answer in this particular order, if we observe, it is going to be for the option C. So the answer for question number 2 is C. Right? So coming forward with the next question, question number 3. So question number 3, what it says is, the maximum number of 4d electrons having a spin quantum number S is equal to half R. Fine. Now S is equal to half. So you need to understand that here all these particular electrons are unpaired, right? So therefore they are speaking about 4d electrons. So you just need to concentrate on the d subshell. Okay. So when we are speaking about the d subshell, what we are going to have is this d subshell has 5 orbitals. 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. Right? So here, this is for your d subshell. So what we have? dx, y, dy, z, dx, z. We have next one dx square, y square. We have last one dz square. This is how everything goes, right? So as the electrons enter into the d orbitals, what we know, it occurs according to the Hund's rule, right? So according to Hund's rule, once the electron comes here, the next electron goes to the next orbital, okay, having the same spin. Okay, so plus half, plus half, plus half, plus half and plus half. Okay, so the next electron what comes? It comes over here. But if it comes here, what will happen is the spins are going to get cancelled here. So that means that I am going to lose 1 plus half here now. If I am going to pair this, I am going to lose 1 plus half. If I am going to pair up here, again I am going to lose 1 plus half, right? So it should be seen that it should be a singly filled. Then I am going to get a maximum plus halves. Okay, so therefore, plus half, how many we have? 1, 2, 3, 4, 5. So, there will be 5 electrons. There are going to be 5 electrons with plus half in the d subshell. Okay, in the d subshell, we are going to have 5 electrons. So, do we have that answer? Yes, and that is the option B here. So, the answer for the question number 3 is 5. Okay, so first try to solve them and then come to the options. Sometimes taking a look directly into options also can be affordable, right? So, let's go with the next question. Question number 4, what it says. The quantum number for the outermost electron is given below as n is equal to 2, L is equal to 0, M is equal to 0, S is equal to plus half. Fine. So now they are saying that there is a particular electron, outermost electron in n is equal to 2. Okay. So n is equal to 2. That means this atom is going to have 2 shells. Let's say this is shell number 1, this is the shell number 2. So we have 2 shells. So only n is equal to 2. This is n equal to 1, n equal to 2. So when this is n is equal to 2, you already know that in n equals to 2 there are 2s and 2p subshells. Right? So we have s and we have p. Now, in order to understand whether the electron is going to S or whether the electron is going to P, you need to know the value of L. What is the value of L given? 0. Value of L is equal to 0, that means the electron is going to the S subshell. In S subshell there is only one orbital, that is the S orbital. So can I say that looking at this particular series, in the first orbit there are going to be just 2 electrons. Next electron will come here, right? This electron is coming into S subshell. In S subshell it is coming to S orbital, and as it is a single one, it will be having plus half as a spin quantum. Okay, so they are asking which particular element that particular thing can be. So as we have 1, 2, 3, only 3 electrons. The third electron has N is equal to 2, L is equal to 0, M is equal to 0, and S is equal to plus half. Right? So there is only one possibility, that is the atom. This is the atom with 3 electrons. Okay, so the atom with 3 electrons, atomic number 3 is nothing more than lithium. So therefore, the answer goes for B, lithium in this particular case. Coming towards the next question here. Question number 5. So, question number 5. The set of quantum number for the outermost electron for copper in its ground state is. Okay. So, first thing we are dealing over here with the copper. So, copper, what we know is the atomic number is 29. Right? So, whenever you are solving such kind of things, you need to understand that what is the electronic configuration. Observe the electronic configuration, go to the end of the electronic configuration, see the last electron. When you observe the last electron, you can understand what is the value of N, what is the value of L, what is the value of M. Okay, and if you can possibly give it in a box type of representation, you will also understand what is the value of S, that is the spin quantum number. Okay, so in this particular case, when we observe electronic configuration, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d10. Okay, exception case for copper, right? So now, what is the outermost shell? Outermost shell is the fourth shell. M is equal to 4 here. Okay, of course, through the energy we have written it prior, but when we construct the shell, the fourth shell is the outside, right? Before that comes the third shell. So therefore, this is the fourth shell. Now, observe at this particular condition. When you observe this condition, you will understand that what is the value of N. Naturally, the value of N in this case is 4 because of this 4 over here. Okay. The last electron is entering into S subshell. So the value of L is going to be equal to 0. As the electron enters into S subshell, in S subshell there is only one orbital, and that one orbital is the S orbital, so the value of M is equal to 0. There is only one electron, it is not pairing up. So as there is only one electron, I can say S is equal to plus of half. So I need to find a particular option having this as 4, 0, 0, plus of half. If I can get this, we have an answer. So, which one is it? It is going to be the option number C. Right? So, this was for the answer 5. Going forward with the question number 6. This is important for us. The orbital angular momentum of an electron in 2s orbital is. Okay, first we need to understand what is the formula for the angular momentum of an electron. Let it be any of these particular orbital. Okay, so angular momentum of an electron. Angular momentum. Please take down this formula. Okay, is of an electron in any particular orbital is given as L into the bracket of 1 h over 2 pi. Okay, so now here observe the electron is in the 2s, right? Now simply by understanding what is the value for azimuthal quantum number for the subshell that is given or for the orbital that is given, you can find out the angular momentum. So therefore for s, what we have, the angular momentum L is equal to 0. Direct answer. So therefore substituting the value of 0 over here, so what we are going to have, 0 into, this is a multiplication, into 0 plus 1 into h over 2 pi. So the complete answer is going to be 0, right? So for the sixth one, answer is C, 0. Moving forward with the next question, question number 7. So, question number 7, it says, the number of 2p electrons having a spin quantum number s is equal to minus half r. So, how many number of 2p electrons we are going to have? Which are going to have the spin quantum number s is equal to minus half. Alright. So, we are speaking with p orbitals. So p orbital. So in p orbital, what we have? We have 3 types, right? Those 3 types are nothing more than, you have px, we have py, we have pz. Okay. So when the electron starts to occupy these orbitals, so first one, what we have, the electron comes here. When electron comes here, the value of s will become as plus half. So can I say one electron is with plus half here? Next electron comes at this particular point. So again plus half. Next electron comes over here to pz. So again we are going to have plus half. Quite simple, right? Now once these orbitals are singly filled, then my electrons will come here and they start pairing up. So when electron pairs up, the spin changes. Spin changes to minus of half. Another electron comes over here, minus of half. Another electron comes over here, minus of half. So can I say, in p orbital, the electrons with minus half spins are 1, 2, 3. There are 3 electrons with minus half of spin, and there are actually 3 electrons with plus half of spins. So my answer for question number 7 is D. That is, there are 3 electrons with minus half as a spin. Going forward with the next question. The next question, arrange in the decreasing order of energies of 2s orbitals in the following atoms: hydrogen, lithium, sodium, potassium. Alright. So they have given us hydrogen, lithium, next one is sodium and potassium. Right? Now, as we go down a particular period, what we know is the size of atom increases. Right? Therefore, as the size of atom increases, can we say that the size of 2s orbital also increases then? Correct? So, as the size of 2s orbital increases, the energy decreases. Remember this concept. As the size of 2s orbital increases, the energy decreases. Okay, so therefore, what we are going to have is, in this case, if I take this into consideration, then the smallest size should have have the greatest energy because it is closer to the nucleus. So therefore, hydrogen 2s orbital should have the greater energy, followed by lithium, followed by sodium, followed by potassium. That means potassium is going to have the least amount of energy. The lowest goes to potassium, highest goes to hydrogen. So therefore, taking a look into this case, what we are going to have is, yes, energy of 2s orbital for potassium is smaller than that of sodium, which is smaller than that of lithium, which is smaller than that of the hydrogen in this case. Okay, so answer D is correct. Going forward with the next question, that is the question number 9. Question number 9. The number of unpaired electrons in Mn plus 3 is 2, 3, 4 and 5. Alright. Now, in order to understand this, first again we need to understand the atomic number. From the atomic number, we need to understand about its electronic configuration. From electronic configuration, you try to remove out 3 electrons, then we will come to the answer. Right? So therefore, taking into consideration of Mn here, so Mn, what do we have? Atomic number. Atomic number is 25. Right? So, electronic configuration will become as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d5. Alright. So therefore, this is the scenario here. Now, what we need to understand is we have to remove 3 electrons in this case. So therefore, we will come across Mn plus 3. Right? So 3 electrons we have to remove. So removing an electron always occurs from the outermost shell. The outermost shell is a 4s again. So 4s will lose 2 electrons. From here it loses 2 electrons. From 3d5 it will lose 1 electron. Okay, so we are going to lose it like this now. Therefore, when we observe, 3d5 will now become as 3d4. So therefore, when we observe this orbitals, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright. So, how many electrons we are going to have? Now, when this particular thing loses 1 electron, then it will become as 3d4. So, 1, 2, 3, 4. So, there will be 4 electrons which are going to be unpaired. So, number of unpaired electrons in Mn plus 3, answer goes for C, that is 4 electrons. Next one. So, the next question is, consider the following set of quantum numbers. Which of the following can be possible? Okay, which of these particular things can be possible? Now here, they have given us the value of n, l, m and s. Always remember the formulas. L is equal to n minus of 1, right? And m is equal to 2l plus 1. Things should get in this particular sequence, or they should follow these particular rules. So, first one, let's observe the first scenario perfectly. N is equal to 3, fine. N is equal to 3, okay. L is equal to 0. Now, L is equal to 0, that means it is one of the values. Okay, that means L is equal to 3 minus 1, that is 2. Now, when we are speaking about 2, that means it is going to be either 0 or 1. 0 goes to S subshell, 1 goes to P subshell, right? So, here they are speaking about 3, 0. Yes, this is correct. M is equal to 0, that means they are speaking about S orbital. In S orbital, they are saying that there is an electron with a plus half. Yes, this is perfect. So, option 1, there is no problem at all. Let's let's observe the second one. Now observe here the way that it is being given. N is equal to 2. L is equal to 2 again. But 2 is not possible here because L is equal to N minus of 1. That means 2 minus of 1 is should be 1. That is going to be only one particular value. 0 and 1 that is. Okay. So that is going to be only one value, that is going to be 0 in that case. So this is not the correct answer here. Okay. So therefore option 2 is wrong. Observe option number 4 again. Option number 4 says that n is equal to 4, L is equal to 3. Yes, it belongs to perfectly to that particular formula. M is equal to minus 2. Yes. Now L is equal to 3. Okay. So L is equal to 3. That means it's showing you an F orbital. Remember 0, 1, 2, 3. S subshell, P subshell, D subshell, F subshell, right? So 3 is perfect. Minus 2, yes, it has a 7 orbitals. Out of 7 orbitals, one of the orbital will have minus 2 as value. Yes, even this is correct. S is equal to minus R. Yes, perfect. Next option, if you see, N is equal to 1, okay, L is equal to 0, fine. If L is equal to 0, then it is S subshell. If it is an S subshell, then what will happen? We cannot have the value as M is equal to minus R. It should be 0. So again, option 4 is wrong. So here what we see is, there are two options which so far are being correct. Option number 5, 3, 2, again 3. Okay, and plus R. Yes. Again, if you apply the same kind of formula, you will find out that even fifth one is a wrong answer. Okay, so option 1 and 3 should be correct in this scenario. So one correction that we have to make here is, it is the option C. They are given as 1 and 2. Actually, it should be 1 and 3. Please make this one correction here. Okay, so C comes as 1 and 3. Going forward with the next question. Question number 11. The ratio of nucleons in O16 and O18 is 9 by 8, 8 by 9, 4 by 5 or 2. So first thing is, we need to understand about the nucleons. So when we are speaking about nucleons, it is nothing more than the nucleus. Okay, so nucleons. So nucleons are nothing more than the sum of protons and neutrons which are present in the nucleus. Now, when we speak about O16, so when we speak about O16, what we know here is that number of protons are 8, number of neutrons are 8. Okay, because oxygen has an atomic number of 8, 8 electrons, 8 protons. Protons 8 plus neutrons 8, 16 atomic mass. Now, when we speak about O18, okay, so here O18, when we observe here, the mass has increased. Okay, the charge has not increased, rather the mass has increased. In such conditions, protons are 8, neutrons are 10. Correct, 10 plus 8 is 18. So now, here, the ratio of nucleons, this ratio and this ratio are same, so nothing to worry about that. While O16 to O18, can we say that it is something like 8 is to 10? 8 is to 10 is nothing more than 4 by 5. Correct? So, the option goes for C, 4 by 5. Coming forward with the question number 12, and that is number of neutrons in chloride ion. Now, if you observe it carefully, you will find that there is a Cl minus. Okay, it is nothing more than Cl minus over here. Okay, Now, in this scenario, what is happening? They are asking us to find the number of neutrons. Now, first thing that we have to know is in chlorine, the number of electrons are 17. If there are 17 electrons, number of electrons should be equal to number of protons. But this is chloride ion. Cl minus is called as chloride ion, which is because of presence of one extra electron. One electron is extra in this case. That means number of electrons are 18. Do not worry about that one. Okay, it's negative charged. Okay, but number of protons will be 7. Okay, we know that they have already given us the mass number over here as 35. So therefore, taking this into consideration, so can we say that protons plus neutrons is equal to 35? Okay, so proton 17 plus neutron is equal to 35. So neutron value is equal to 35 minus of 17. So when you do this, the total number of neutrons you will get over here as 18. So answer again is C, 18. Alright? Moving forward with the next question. And that is the heaviest particle is coming to the next question, that is the heaviest particle is protons, neutron, electron, positron. Now here in this particular scenario, what we need to understand is that the electrons are the species with the lightest mass, right? So therefore, electrons and positrons are opposite to each other. Positrons are anti-electron type of species, okay, with the charge as +1 and mass is equal to electrons. Now in this entire scenario, when we see the heaviest particle among all of them is nothing more than a neutron. So neutrons are the species, neutrons are the species with the mass as 1.008 AMU. So the answer here is B. Okay, so answer is B in this case, that is the neutron. Going forward with the next question. 14th, the increasing order of energies of X-rays, Y-rays. The increasing order of energies of X-rays, gamma rays and UV rays is. Okay, so now we need to observe the spectrum. So when we take a look into the spectra, the entire spectrum of all the radiations into consideration. Alright, so what you observe there is the first sequence here is for the gamma rays. Alright. So, followed by the gamma rays is the X-rays. So, gamma rays, here comes as the X-rays. Okay, so next one is actually the UV rays. Then comes is the section where we can observe the things, visible rays. At the end here is going to be the IR. Right? Then comes microwave, and finally, as what we have here, at the end is going to be the radio waves. Okay, so this is a sequence. So, you should understand that when we are going from the left to the right in a spectrum, okay, what happens is the frequency or the energy goes on decreasing. Okay, that means these have the highest frequency. Okay, as we come from the right to the left, here wavelength goes on decreasing in a spectrum. So therefore, remember this sequence. So here, frequency of gamma rays is the highest one, followed by the X-rays, followed by UV. Okay, so far they have asked us only these three. So taking this into consideration, as we see there, what will happen is the gamma rays followed by X-rays. So option A is gamma rays and UV. So option 1 is wrong. Next one is gamma rays followed by the X-rays followed by the UV rays. Yes. So option B is the correct answer for question number 14. Coming forward with the next one. So if you observe question number 15 here, what it says is if lambda 1 are the wavelengths for the X-rays. So they are speaking with respect to the X-rays here. So X-rays they are studying as the lambda 1. Okay. Next. And lambda 2 are the wavelength for microwave. So microwave is over here. Okay, so this is the lambda 2. As I have already explained, as we come from the right to the left, what is going to happen? The wavelength or the lambda goes on decreasing. That means I should know that microwaves have higher wavelength than that of the X-rays. Okay, but of course the energy or the frequency for the microwave is lesser when we compare to that of the X-rays. So now, when we observe this scenario, what do you have to remember? Lambda for microwave is greater than the lambda for the X-rays. So therefore, let's observe the options now. Lambda 1 is equal to lambda 2? No, not correct. Lambda 1 is greater than lambda 2? No. Lambda 1 is smaller with respect to the lambda 2? Yes, the option C seems to be correct in this scenario. Alright, so question number 15 goes for the answer C. Alright, coming to the question number 16 now. The ratio of specific charge of proton and alpha particle is. Alright, let me tell you protons. Specific charge. Now when we speak about the specific charge for the proton, over here is going to be 9.6 into 10 raised to 7 coulombs per kg. While alpha particles, what are alpha particles? This is nothing more than the doubly ionized helium particle. Remember, it is doubly ionized helium particle. When we are speaking about doubly ionized helium particle, that means it is going to contain 2 protons plus 2 neutrons. Okay, so now, when it contains 2 protons plus 2 neutrons, that means it is the 4 times. It is 4 times when I compare to that of proton. Okay, it is 4 times to that of protons. So therefore, specific charge. First, I need to understand about the specific charge for the alpha particle. So, specific charge is given as the charge over mass of protons. Okay, so for an alpha particle, it is going to be as 2 into 9.6 into 10 raised to 7. The whole thing divided by. So it is 2 plus 2, that is 4 times the mass, so 4. Okay, so 2 once, 2 twice, so it is going to be around 4.8 into 10 raised to 7, right? So I know that specific charge for proton is equal to 9.6. Okay, so proton to alpha particle is 9.6 into 10 raised to 7 used to 4.8 into 10 raised to 7, right? So it is something like once, twice, so 2 is to 1 will be the ratio. So if we have that, no. Can we write it in another form? That is going to be as 1 is to half. Okay, so this is 1, this is half of this. So 1 is to half. So this option that we have over here as A. Or you could have also gone for 2 is to 1, but as we do not have that option here, I try to figure it out in the other way. Right? So this is for the question number 16. Right? So Okay, coming towards the next question, and that is the question number 17. Wavelength of a photon with energy as 1 electron volt. Okay, so first thing, 1 electron volt in terms of joules is going to be as 1.602 into 10 raised to minus 19. Remember this one. Okay. So it is going to be in the form of joules. Now, here they are asking us for the wavelength, so that lambda is equal to h into c over e. This is the expression whenever you need to find the wavelength of a proton. So you need to take down this. So here, constant h is equal to 6.626 into 10 raised to minus 34. Okay, what do we have? The next one, velocity is equal to, that is going to be 3 into 10 raised to 8 meters per second. Next one is the energy. Energy is taken in the form of electron volts, and that is 1.602 into 10 raised to minus 19 joules. Right? So therefore, taking this entire scenario into consideration and substituting, lambda is equal to 6.626 into 10 raised to minus 34 into, what do we have next one? 3 into 10 raised to 8, the whole thing divided by, what do we have is 6.1, sorry, is 1.602 into 10 raised to, how much is it? Minus 19. Alright, let's take this particular minus 19 on the top, it will become as plus 19. So plus 19 plus 8, it becomes as 27. So 27 and minus 34, it becomes as around minus of 7. As lambda is equal to 10 raised to, over here minus 19 goes on the top, it becomes as plus 19 plus 8 plus 27 plus 27 and minus 34, you will get it around minus of 7. Okay, so when we multiply 6.626 into 3, we are going to end up having the answer as 19.87. Okay, so this particular value will be around 19.87. So divided by 1.602, you will end up having an answer as 12.40. Okay, 12.40 and so on and so forth. So therefore, here they have asked us in form of angstroms. So angstroms, when I shift this particular digit over here, decimal to 1, 2, 3. So it is going to be around 400. Okay, 1, 2, that is 1, 2, 3. Okay, so that is going to be in the form of angstroms. So I need to have a value nearby 12400 angstroms. Okay, 12400. Okay, fine. The answer, that is the A, that is correct over here. Okay, approximately the answer is going to be as 12,400 angstroms. Here it is 12,420 angstroms. So you can expect the answer A in this scenario, right? So okay, so the next question is the energy of photon is, so taking into the same consideration, that is lambda is equal to h into c over e. Here what they have given is the energy as 3 into 3.03 into 10 raised to minus 19, okay, per atom. Alright, so the wavelength of photon is, now they have directly asked us what is the wavelength of the photon, taking into consideration of the same formula. So what we are going to have here is lambda is equal to h 6.626 into 10 raised to minus 34 into 3 into 10 raised to, let's say, 8 to here, the whole thing divided by 3.03 into 10 raised to minus of 19. So lambda Over here, again, same way, you are going to get here as minus of 7 because of this. Minus 19 goes on the top. So it becomes as plus 19, plus 8, 27. 27 minus 34, you will get over here as a minus 7. Okay, so 3.03 and this one once over here 1.01, right? So when you divide this, you are going to get it nearby 6, 5, 6. Alright, fine. So okay, fine. So we are going to have 6.56 into 10 raised to minus of 7, okay, meters. So if we shift this decimal to 1, 2 places, that is 656 into 10 raised to minus of 9 meters. So this one is nothing more than 656 nanometers. So the option over here should be 656 nanometers. Okay, so answer is B. Next question, question number 19 over here is that the Bose theory explains us about Zeeman effect. No. Stark effect does not explain. It explains the spectra of hydrogen atom only, right? It is not going to explain us about the spectra of electron having more than one electron also. So option C for question number 19. Followed by the Stark effect refers to, it refers or it deals with the splitting of the particular spectral lines under the presence of electricity. So the splitting of spectral lines in the electric field is going to be shown by the Stark effect. So for today, for this video, we complete 20 problems or 20 multiple choice. In the next video, we will be taking a look of the continuation from this point. Take care.